Hi, this is Sonia Doucette. In this problem, I'm going to show you how to find the number of photons or the moles of photons when you know the wavelength and the total amount of energy. This problem says that chlorophyll A in a plant absorbs blue light of wavelength 430 nanometers. If a plant absorbs 8.37 kilojoules of this light in one day, how many moles of photons at this wavelength are absorbed? So what we want to find is moles of photons. And we know two things. We know the wavelength of that light, and we know the total amount of energy absorbed in that day, 8.37 kilojoules. So if we know the total amount of energy, and we can figure out the energy in one photon, so the units here would be joules and joules per photon, then we could find the number of photons. And then we could use Avogadro's number to get us from the number of photons to moles of photons. So we're given energy total, and we want to figure out the energy of a photon. So we can do that through the following relationship. The energy in one photon is equal to Planck's constant times the frequency, and then we also know that frequency is equal to the speed of light over the wavelength. So to directly relate wavelength, which we're given, to the energy of one photon, we can just plug in the speed of light divided by wavelength for this frequency term. So the overall equation we would get there is the energy in one photon is equal to Planck's constant times the speed of light divided by wavelength. So plugging in our numbers, we get 6.626 times 10 to the negative 34 joule seconds times 2.998 times 10 to the 8th meter seconds divided by our wavelength, so 430 nanometers. Because we're dealing with the amount of energy in one photon, the energy units we want are going to be joules, so we need everything else to cancel out. So far the seconds will cancel, but our units of length, meters and nanometers, are in different units, so we need to convert one to the other. So I'm going to convert nanometers to meters by saying that in 1 meter there are 10 to the 9th nanometers. And here now nanometers cancel, meters cancel, and we're left with joules. So if you do the math here, you'll find that the amount of energy in one photon at this wavelength is 4.6197 times 10 to the negative 19 joules per photon. So now what we need to do is plug this number into the denominator here and divide it into 8.37 kilojoules, which is what we're given. So we're going to take 8.37 kilojoules and divide it by this 4.6197 times 10 to the negative 19, and that's joules per photon. So we want the units of energy to cancel out, but we can't do that right now because we have kilojoules and joules. So I'm going to convert kilojoules to joules by saying that there are 1,000 joules in 1 kilojoule. So now kilojoules will cancel, joules will cancel, and we're left with photons. So we have 1.81 times 10 to the 22 photons. Then we divide that by Avogadro's number, and we're left with 0.030 moles of photons. And that is our answer.